Okay, Assalamualaikum and good day. So this video will be on the Rolle's theorem. Okay, let f be differentiable on the interval AB and continuous on the interval AB. If fa equal to fb is equal to 0, then there is at least one point C in the interval AB where f prime C equal to 0. Okay. Here, the idea behind the Rolle's theorem itself is actually, let's say we have the intervals between A to B in our graph, in our function, for example. So, there is at least one critical point in between the interval. Okay, that means, remember f prime x is equal to 0 is when we want to find the critical value. Okay, so that means here, what the idea behind Rolle's theorem is that if we have an interval that is between A to B, there is at least one point C where f prime C equal to 0. That means there is at least one critical point. Let's say for the next graph, we have between A to B. Okay, we have two actually critical points, since we have here C1 and then C2. That means in between A to B, we have two critical points where f prime C equal to 0. When we substitute f prime C1 equal to 0, and then f prime C2 is equal to 0 too. That means it can be one or more points. Okay, critical points. That means critical points that might be the minimum value, the minimum point, maximum point, or maybe a saddle point. Okay, for example here, you need to determine whether the hypothesis of Rolle's theorem hold for the following functions and the given interval, and if they do, you need to find the value of C that satisfies the conclusion of the theorem. Okay, so the first one is fx equal to s cubed minus 3s squared plus 2x on the interval 1, 2. So here we have A equal to 1 and B equal to 2. So we need to test actually whether fa and fb equal to 0. Then only it satisfies the Rolle's theorem. Okay, so right now, when we substitute 1 in fx, we have 0. And 2 in fx, for f2 we have 0. Therefore, f1 equal to f2 equal to 0. It satisfies the Rolle's theorem. Okay, since it satisfies, we need to find the value of C. Okay, so we need to use this equation actually, f prime C equal to 0, which means first we need to determine f prime x. Okay, f prime x is equal to 3x squared minus 6x plus 2. Differentiate fx here with respect to x. Okay, so next, f prime C equal to 0, which means 3c squared minus 6c plus 2 equal to 0. Substitute C in fx. Okay, and then after you have calculated, using your calculator actually, you will find two values of C, which is C equal to 1.5774 or 0.4226. Since C is on the interval 1 to 2 here, therefore we will be only choosing C equal to 1.5774. 0.4226 is outside of the interval. So we only need the point which is inside the interval. Okay, if you want to find it manually, you can also use this formula. C is equal to negative B plus minus root of B squared minus 4AC divided by 2A. Okay, so the next example. Let's say we have fx equal to 5x squared plus 7x minus 6 on the interval negative 2 to 3. So here we have A equal to negative 2 and B is equal to 3. Substitute negative 2 in fx, we have 0. Okay, that's clear. Substitute 3 in fx, we have 60. Okay, f negative 2 is equal to 0, but f3 does not equal to 0. Therefore, fx does not satisfy the Rolle's theorem on the interval negative 2 to 3. Remember, we need to have two x-intercept. Okay, here. the idea for the Rolle theorem is in between two x-intercept, here A and B, there should be at least one critical point. But since here right now, x equal to -2 is an x-intercept, but x equal to 3 is just a point plotted on the graph and it's not an x-intercept. Okay, that's why it does not satisfy the Rolle theorem on the interval -2, 3. You need to state the interval. Okay, compulsory. Okay, next. We have fx equal to root of 9 minus x squared on the interval 0 to 3. So, a is equal to 0 and b is equal to 3. Okay, f0 is equal to root of 9 minus 0, which is equal to root of 9 equal to 3. And then f3 is equal to root of 9 minus 9 equal to 0. Since f0 does not, since f0 does not equal to 0, therefore fx does not satisfy Rolle's theorem on the interval 0, 3. Okay, that's it. If you have 0, that means you have f0 equal to 0, you can continue to actually determine f prime x and hence determine the value of c when f prime c equal to 0. But here we have f0 equal to 3, which is not equal to 0. That's why fx here does not satisfy the Rolle theorem on the interval 0 to 3. Okay class, thank you.